Hey everyone, this video is going to be on a sub-area of ballistics known as internal ballistics, and in particular we're going to talk about what exactly is a bullet, what is caliber, and what is rifling. So firstly, there's a misconception that this overall unit is a bullet, but this overall unit is actually called a cartridge. So a cartridge is what is entered into the gun itself before firing. The bullet portion is the projectile which actually exits the barrel of the gun when fired. So there's all kinds of different bullets out there, and the bullet is actually the top portion of the cartridge here. This part is going to actually exit the gun. So the different parts of the cartridge, there's of course the bullet, there's the casing, right, the bullet case, and contained within the case is the propellant of gunpowder, and there's also a primer at the center of the bottom of the cartridge, and surrounding that is the rim, which is often has a head stamp which gives you some details about what type of cartridge it is essentially. And so this particular cartridge is designed for handguns, for smaller guns, what we're looking at here. But this type would be for longer guns like a rifle. It's going to follow the same premise though, all of these different types of guns. So how does that work? Well, it helps to kind of think back if you look at the way that the muskets used to be fired, where we can picture they're loading up the gunpowder into the barrel of the gun, they're dropping the ball into the gun and then lighting a fuse, which then the gunpowder launches the ball forward. Similar premise today, it's just that it's much faster today, right? So the way that it works is at the back of the cartridge, it's all self-contained. At the back of the cartridge is the primer, and part of the gun strikes that primer. That sudden pressure creates a small explosion or a small spark, and that spark ignites the gunpowder. The gunpowder then launches the bullet out of the cartridge, leaving the shell casing behind. So this is a visual of what that would look like. Pressure applied to the primer, small spark ignites the gunpowder, and then fires the bullet, essentially. So this is more of what a cartridge would look like for a longer gun. For a shotgun, similar premise but slightly different. Again, we have a primer, we've got our gunpowder, but instead we have our shot, which instead of being a single projectile bullet, is actually several little balls that are going to be scattered when they're fired, essentially. But all following the same premise. And so there's all kinds of different cartridges for all different guns. So how do we know what to use for which gun then? Well, the answer is the caliber. So the caliber is technically a measure of the inside diameter of a firearm barrel. So here's the barrel, the part where the bullet exits. And so essentially we're just saying, what is the width of the barrel? That's the caliber. So if somebody has a 9mm type of gun, what we're saying is that the barrel of that gun is 9mm in internal diameter, essentially. Another way to define the caliber is the measure of the diameter of the cartridge. So the cartridge is also going to be that same 9mm in width, which makes sense because you can't force an overly large bullet through the barrel. They have to fit the same size. So the calibers need to match. Now this obviously isn't to scale. My 9mm here for the cartridge width is smaller than the barrel width, but in real life obviously the 9mm, it would be the same 9mm essentially. So those two have to match. The width of the cartridge has to match the width of the barrel. And so caliber is class evidence, right? So if you're an investigator, you find these bullets at the scene, one of the first things you're going to do is measure the width of the bullet, measure the caliber. And that's going to help to narrow your field of what types of guns could have fired this bullet. It's not going to tell you exactly which gun, but it could tell you a bunch of different guns that could have fired it. So how exactly does a gun fire a bullet? So we're looking at these cartridges here, and when you pull the trigger, it causes the hammer to strike the firing pin. The pin then strikes that primer that we talked about earlier. So here is a cartridge where the primer is still intact. It hasn't been fired. This is before it's been loaded into a gun. And then this is the shell casing left behind, where you can see that primer has a firing pin indent. So the firing pin struck that primer, which then sets off that reaction we talked about earlier. After that happens, then you can see that the bullet exits through the front of the gun, through the barrel, and then the shell casing is left behind. So even though guns are going to vary dramatically, they're all going to follow the same general premise of how the trigger and firing works, essentially. So then, what are lands and grooves and what is rifling? Well, within the barrel of a gun, is something called rifling. It's the spiral pattern of lands and grooves in the barrel of the firearm. And so what it is there's actually a spiral pattern created, and it's like a track that the bullet needs to follow. As we saw before, there's nothing really directing the bullet, it's just being launched forward. So after it gets fired into the barrel then has the spiral pattern of indents that we called grooves and elevated portions that we call lands. And so those grooves and lands are arranged in a spiral pattern. And what's going to happen is the lands are actually going to scrape up against the bullet because they're more coming out, they're elevated as the bullet passes through, and the grooves are not going to scrape as much against the bullet. But both the lands and the grooves are going to spiral together. And so because of that, it's going to force the bullet itself as it goes through to spin, to spiral. Now, why would we want a bullet to spiral? It's the same principle essentially as why a quarterback wants a football to spiral. It's for maximum accuracy over long distance. The quarterback doesn't want the ball to tumble or to go off target, and a spiral guarantees that it'll go to the place they want it to go to. So a gun also has that same spiral for maximum accuracy, and it's created as a result of those tracks from the elevated portion called the lands and the depressed portion called the grooves. And you've actually seen something like this before, and I also wanted to show you an example of a spinning bullet in real life. Okay, so what we're looking at here is an actual bullet that's already been fired, and we notice that they're sort of alternating. There's some shiny parts and there's some scrapes, shiny parts, scrapes. The shiny part is a result of the bullet passing through and going through a groove portion. So this bullet, as it was fired, did not get scraped up against because the groove portion was there. Whereas the next part of it would match up with a land from the gun. So the land of the gun is actually indenting into the bullet and leaving a scrape mark behind. And so the reason why that matters is because each gun is going to leave a certain scratch pattern behind as a result of these lands and grooves designed to make the bullet spiral. So that's going to help us identify which type of gun fired it. And so you can have a left twist or a right twist depending on the direction of the spiral in the gun. And you can kind of see, here's what a bullet would look like if it had a left twist when it was fired, and here's what it would look like if it had a right twist when it was fired. There's alternating marks from the lands and grooves that help us determine. So what is the process then? Well, first you collect bullets from the crime scene. And then you also collect the guns from the suspect. You test fire the suspect's gun into a barrel of water. The reason why it's into a barrel of water is to try to stop the bullet and leave it intact. And so once we fire that bullet, we can then take it out and examine it. We take that bullet and examine it, and we measure the lands and the grooves that are left on that bullet as a result of the firing, those scrape marks. And so we compare those to the bullets that we found at the scene. And in particular, we use something called a comparison microscope. So this is a special microscope that actually allows you to look at two things at once and compare them very closely. There's two different lenses on this microscope. So why does all this matter? Well, the lands and grooves, the presence of the rifling thing, and also, so like, does it have rifling, does it not have rifling inside the barrel, and also the direction of the twist, is it right, is it left, and also how wide are those lands, how wide are those grooves, are all going to be class evidence. We would expect a certain type of gun to have all of these determining factors, like, oh, this revolver, for example, always produces this width of land or this width of groove mark within on the bullet essentially, or this type of gun always has a right twist. However, what's even more important is that there are also pieces of individual evidence left on the bullet. So what we're looking at here is a picture of an examination under that microscope we talked about earlier, a comparison microscope. This looks like it's one bullet, but it's actually two different bullets. The left side of the picture is examining one bullet, and the right side is examining the other bullet. And we notice that they both have this indentation of the same width. So we can tell it was the same type of gun by this scrape mark indentation of the same width on both. But what makes this individual evidence is particularly those striations. So these particular marks that are on the bullet, essentially. It's sort of like a barcode. Every gun is going to have slightly different markings from its manufacturer. Even though the type of rifling is going to be the same, when the rifling is made, it's going to scratch into the gun a unique way, each different gun that's made. And so if we look under a microscope at those minute details, and if we still get a match of those exact striation marks, then we can know that this is that gun that fired it. Not just the type of gun, but this bullet came from that gun, if both bullets have the same exact minute striation marks, essentially. Those marks, there's also marks that could be created just from wear of the gun, right? So anything that's going to be unique to that gun versus the things that are just manufactured for guns in general are going to help us identify a suspect. So here is a video of just sort of the general process as well.
Recover marked fired bullets. Use a stereo microscope to determine the presence and quality of microscopic marks on the bullets prior to examination under the comparison microscope. Place one of the fired bullets on the right stage of the comparison microscope. Attach the nose of the bullet to the mount. Adjust the lighting from the rear of the microscope to provide oblique illumination over the bearing surface of the bullet. Examine the entire bearing surface of the bullet using low magnification, 10 or 20x, to determine the best area of individual characteristics. When such an area is located, leave the right stage in that position. Place the second bullet on the left stage with the nose in the same direction as the bullet on the right stage. Rotate the bullet from the left stage looking for the same area of individual characteristics as on the bullet on the right stage. The entire surface of the bullet should be considered. Higher magnification should be used to verify correspondence of finer striations. If an area of correspondence is found, align the land and groove impressions and rotate both bullets simultaneously. Examine and compare each land impression and each groove impression area from the base to the nose until a conclusion can be drawn that there is or is not sufficient agreement for identification.